All right, so you think you know how the world works, right? Well, get ready to have your mind blown. Today, we're diving deep into the rulebook of the universe itself, and trust me, it is way, way weirder than you could ever imagine.
So let's just jump right in with the biggest question of all. What really makes everything tick? I'm not talking about planets spinning or cars moving. I mean, what's happening at the most fundamental, rock-bottom level of reality?
Well, it turns out the universe has a kind of secret instruction manual.
And that manual is called quantum physics. Basically, it's the physics of the unimaginably small. We're talking atoms, electrons, all the tiny bits and pieces that make up, well, everything. And down at that level, the rules of our everyday world just get thrown right out the window.
Okay, so the best way to wrap your head around this is to think of it like this. We're living in two worlds at the same time, and each world plays by a totally different set of rules.
So, you've got our world, the classical world. If you throw a baseball, you know exactly where it is and where it's headed. It's simple, it's predictable. But then, there's the quantum world, and oh man, things get weird. Down there, a particle isn't in just one spot. Nope. It's kind of smeared out, existing in a haze of all possible places at once. And here's the kicker, the part that sounds like science fiction. The moment you try to look at it, to measure it, poof, it snaps into one single location. Your act of looking literally forces reality to make up its mind. How wild is that?
So, to really get a feel for this, let's break down 3 of the most mind-bending ideas from the quantum realm. Ready? Okay, concept number 1, and it's a big one, wave-particle duality.
So think about an electron. Is it a tiny, solid bullet zipping through space? Or is it more like a wave, a ripple spreading out in a pond? The quantum answer, which is just bonkers, is it's both. At the same time, it all depends on how you measure it. It's like a platypus, right? You can't call it a beaver, you can't call it a duck, it's just a platypus. It breaks all the neat little categories we try to put things in. Okay, so if being 2 types of things at once wasn't enough for you, how about being in multiple states of being at once? That brings us to concept number 2, superposition. You've probably heard of this one, Schrödinger's cat. The idea is you put a cat in a sealed box with something that has a 50-50 chance of, well, ending the cat's 9 lives, based on a random quantum event. Now, until you open that box and look, that quantum event is in a superposition. It has both happened and not happened. Which means, and this is the crazy part, the cat is simultaneously both alive and dead. It's only when you open the box, when you observe it, that reality is forced to pick one. The superposition collapses into a single state. It's a bit of a morbid example, sure, but it perfectly shows how observation is a fundamental part of quantum reality.
And now for our third and final concept. And honestly, if you thought the other 2 are weird, this one is on another level. It's called entanglement.
This idea was so strange, so unbelievable, that Albert Einstein himself couldn't get on board. He famously called it spooky action at a distance.
Let's put it this way. Imagine you have 2 coins that are magically linked together. They're entangled. You spin them both, and you give one to your friend who travels to the other side of the universe. The second you look at your coin and see it landed on heads, you know with 100% certainty that your friend's coin instantly landed on tails. It's not that the information traveled, it's that their fates were linked from the very beginning, no matter how much space is between them. It's a deep, mysterious connection woven into the fabric of the universe itself.
Okay, so at this point you might be thinking, this is cool, but so what? It's all just weird thought experiments, right? Wrong. This spooky, mind-bending science is actually the engine that powers our entire modern world.
Think about it. Lasers? That's quantum physics. The fiber optics that bring you this very content? Quantum physics. MRI machines that let doctors see inside you without a single cut? You guessed it. The tiny transistors that are the building blocks of your computer, your phone. Every single one is a quantum device. This isn't just abstract stuff, it's the foundation of almost all modern technology.
And believe it or not, we're just getting started. Everything we've talked about is now leading us to the brink of a brand new technological revolution.
I'm talking about quantum computing. By actually using these bizarre properties like superposition and entanglement, scientists are building computers that can solve problems that would take today's best supercomputers millions of years to crack. We're talking about revolutionizing medicine, creating new materials, you name it.
So you see, getting to know the quantum world isn't just a fun mental puzzle. It's like we've been handed the universe's ultimate instruction manual. These rules are weird, they are powerful, and they are already changing everything. And that leaves us with a huge question, maybe the most important question of our time. Now that we know the rules, what are we going to build with them?